Hello everyone and welcome back. I'm Kev the Dev. And today I'd like to talk to you all about keeping our data that's online safe and private. There are many different forms of data that you transmit over the internet, like the data that you store in online file storage websites, the personal data and info that is kept by companies on your behalf, and personal, sometimes intimate, private messages that you share with your friends and family. So today we're going to focus on how we keep that data that you're sending private and secure, because as it travels along the network out in the world, there are many bad actors that would like to look at that data. So let's dive in. Something that many people might not know is that messages traveling along the wires, along the networks, are actually observable by anybody willing to listen. Think of it this way, and this is an oversimplification, but a device on a network communicates with other devices on the same network or other networks by basically screaming really loud until the person that it's trying to communicate with listens. And anyone or anything with the easily available software can listen to those screams. Yes, I know it sounds scary, but it is true. You're talking from point A to point B, and I can insert myself in the middle and observe your messages as they go across. Anything from Facebook messages to iMessages, online store checkout forms where you're entering in your credit card information. As I mentioned, some private messages that you're trying to send to your family. All of that stuff is encoded typically in a protocol called HTTP, which stands for Hypertext Transfer Protocol. This super common protocol is understandable by most devices operating on the internet. And don't worry about too much about what it is, but just know that it's kind of like a language that all of these devices on the internet speak. And it is visible to anyone. Well, sort of. How can we protect ourselves? Well, we, as users of the network, we need a solution that will protect us and our data without causing us any significant inconvenience like time or inconvenient hoops to jump through to get my data from point A to point B. Wouldn't it be great if we could just continue using our browsers the way that we always have, but with additional protections? Enter encryption. You may have heard this super fun word in combination with other really fun terms like hacker, cybersecurity, or cryptography. In simple terms, encryption is when we shuffle our data that we send over the network in such a way that anyone who sees it cannot understand what they're looking at. So they can still see the data, but it just looks jumbled and nonsensical. Now, the oldest and easiest to understand form of digital encryption is called symmetric key encryption, which is a fancy way of saying that both parties in a communication forum need to both have the same key to lock and unlock the data. That is to say, you use the same key to encrypt and decrypt the messages that you're sending. But there's a problem in that scenario. In order for both parties to have the same key, we have to share the key with the parties. So you need to somehow send the key from you to the next person that you're trying to talk to. And if that communication isn't secure, then an attacker could just steal the key and you have an insecure system. So that type of encryption usually entailed physically bringing a key in a briefcase or in some other physical form to the secondary person that you're trying to talk to. And from that point on, you use that key to encrypt and decrypt data. Then this new fancy way of encrypting things that doesn't require you to physically bring a key anywhere came about. And it's called asymmetric encryption. It's also called public key encryption. And it works like this. You've got two keys, a public one and a private one. Your public key is basically a special key that tells the world, here's how you can scramble information to send it to me. And then the private key is something that I keep to myself, and I know how to unshuffle the data, and only I do. So you can freely give out your public key to anybody, because while they can encrypt data, they can't decrypt it. It's an asynchronous process, and that key does not work both ways. And that relies on some fancy mathematics under the hood that is really easy to transmit data in one direction and very difficult to take the data and de-shuffle it, which is why you have a private key which is basically the solution to the math problem that lets you decrypt the data really easily. So internet browsers like Google Chrome and Safari and Firefox, etc., they actually use both forms of encryption. They'll use asymmetric public key encryption to initiate what's called a handshake. So when you initially connect to the internet using your browser, your iPhone, and you're sending an iMessage, Facebook messages, whatever it is, your browser is first going to set up a public key encryption handshake, which is that complicated math problem, which says, here's my public key, encrypt something, send it back to me. Once we've established that we are who we say we are, I can actually send you a symmetric key that we talked about earlier, and we will use the symmetric key for all future communications because it's faster, but that initial handshake is done using that public key encryption. So this special type of encryption is usually denoted in your browser by a green security lock in the URL bar so that you know your connection is secure. So anytime that you use a browser and you see HTTPS, S stands for secure, and that green lock, or on certain browsers, it's just a normal lock symbol, and then you try to buy things with your credit card, you're sending sensitive messages, etc., you can be assured that anyone that's eavesdropping and listening in on your conversations, they're only seeing a jumbled mess of characters, letters, and numbers that doesn't mean anything. Lastly, I want to talk a little bit about something called VPNs, and we've touched on this before, and I'm going to do a separate video on them in depth in the future. But you might have heard something about them through commercials or a friend. What these magical products do are they let you connect to the internet through a secondary computer, and then the world will see you as if you were on that other computer. And typically, all communication between your computer and this secondary computer are secured and encrypted using that same encryption technique I just described. Now, this adds a layer of encryption and security by preventing people on your local network, maybe you're at an airport or a cafe or a coffee shop, who, again, can easily acquire software to eavesdrop on the network. They won't see anything if you are using that VPN, which is great, but it's not perfect. VPNs protect people from a few things, but in the context of this conversation, they protect you from eavesdroppers. Now, if you were using a website protected by HTTPS, then that's also going to protect you from eavesdroppers. Now, we've already talked about that. What if you go to a website that doesn't have HTTPS and you are still concerned that people are listening to your messages and your data? That's where the VPN can come into play. Because all your information is encrypted from the source or your laptop or whatever to that secondary computer, anybody listening on the network that you're on, like the Wi-Fi network at the coffee shop, they're not going to see any real information. It's just going to be jumbled, encrypted nonsense. But what you need to remember about this is that once your communications reaches that secondary computer, that is where the VPN's encryption ends. Because from that point on, the VPN computer acts as a normal computer on a normal network. So basically, after your information passes through the VPN and goes to the destination website or wherever you're trying to access, it's fair game to the internet. So if that website is irresponsible and doesn't implement HTTPS, someone can still technically eavesdrop wherever that server is located, though it's not terribly likely, but it's still possible. Now, that's only a small part of what VPNs do, and it's not really their primary purpose, but you'll see in some of the marketing that VPNs offer this great secure product to keep you safe. And while to a certain extent that is true, it's not the end-all be-all. And you should still be trying to use websites that implement HTTPS. So I'll go into more detail on VPNs in an upcoming video, comparing some popular ones and the features that they have. So to sum all of this up, we utilize encryption to shuffle and deshuffle what we send and receive to other parties like websites so that observers cannot steal our information or understand what we're talking about. And this is done through a very interesting handshake of keys where your browser and the website server act as two parties in a conversation. They exchange identification to each other and agree to discuss things secretly using a private key. And you can gain an added layer of protection by using a virtual private network or a VPN to encrypt your traffic that goes from your computer to the VPN server, but it doesn't cover the entire path of the request. so it's not perfect. So I hope this helped explain a little bit about how our data travels along the internet and stays secure. I know it wasn't extremely in-depth or comprehensive, but I wanted to share the high level with you all. Thank you all for watching and supporting my channel. Please like this video if you enjoyed it, and please comment on anything else you'd like to discuss or learn about in the technology space. Don't forget to subscribe. I'm Kev the Dev, and I'll see y'all next time.